Hello everyone, and welcome back to the next video in our OrCAD X keyboard series. My name is Adam, and in this video, we are going to cover the power stage for our OrCAD keyboard. Now, the only thing that I did since the previous video is I simply added some net name aliases to these QSPI wires here. Nothing crazy. So what we're going to do is jump into this power page and add our USB connector and our linear voltage regulator, which is going to take the USB VBUS, which is a 5-volt power rail, and convert that into 3.3 volts for us so that we can hook it up to our microcontroller. So to start, let's go into our component explorer here. And we need to grab a USB connector. Now, for this specific project, I'm using a USB-C type connector. At the time of making this video, it's just the most common connector. It's also very easy to plug in, right? You don't have to fiddle it both ways, figure out which way works. And the other nice thing is that the footprint that I found, or the part that I found, has a pretty easy to place and route set of pins, right? So regular USB-C connector has, I don't remember, maybe like 24 pins, something like that. But this one has a reduced number of pins because it is specifically made for USB 2.0 type interfaces. So let's go ahead and grab this one down here. Place it on our schematic. Now you'll notice here that I have pins A1, 4, 5, right? So we're skipping a couple pins. And that's again because the USB-C default connector has, up to A12 and B12, so it's 24 total pins. But this is reduced, so we have 2 pins on each side for our data plus and data minus on the USB interface. We have a couple pins for power, a couple pins for ground, and then other than that, there's 2 CC pins which we'll have to connect, and of course our mounting pins or our shield pins. So let's just go ahead and wire up our power pins first. So on the right side here, I'll be looking over to the right side of the screen, and it might be mirrored because of the camera, so it might look like the left side for you guys. So pins A4, A9, and B4, B9, these are our power pins. And I'm just going to wire them upwards, as I like to point all of my power up when possible, and grounds downwards. And we can then go ahead and add a power symbol here. So we're going to place power, and we'll use that power bar again. And then we'll change the net name here to plus 5V0. This is our VBUS, our 5-volt power net. And then this is going to go over to the right side here where we'll have our linear voltage regulator. Linear voltage regulator. I'm going to need a glass of water here pretty soon. All right, so the next thing we need to look at is our ground pins. So A1 and A5 on this specific connector look to be ground. And A5. Let me make sure I actually read that correctly. Nope, just A1 and A12. My bad. So A1, A12, go to ground, and then B1, B12, as these are going to be mirrored, go to ground. Now we'll go ahead and just place a nice little power symbol here. So place, ground. Now you don't have to look for this symbol every time. We can just jump back into our controller page, take one of these ground symbols here, Control-C, paste it on our power page, Control-V. So I'll go ahead and do that. And then we need 2 resistors, 5.1K, and this is specified, I believe, in the specification for USB-C type interfaces. We need a resistor, 5.1K on the CC1 and CC2 pins. So here's a 5.1K resistor. I'm going to do right-click place. And let's drop that down right here and right here. And what these do is they basically set some internal reference to, what voltage should be output on the USB-C connector, and also what type of communication it should expect, right? So if you connect a USB-C to USB-C wire to a, USB 4.0 interface, and then on the other side to some regular old USB 2.0 interface, they can still communicate because these CC pins will basically let the device know, hey, we're still going to communicate over USB 2.0. And by the way, this is not USB power delivery, which can go up to, I think, 12 or 24 volts. This is regular old USB 5 volts that we need on the power output. So the first one, the CC pin here, is on pin A5, and the second one is on pin B5, which is not this one, it is this one here. Nope, that's B6. B5. And then finally, these need to be also connected to ground. So just like that, and like that. And then let's see, we want these mounting holes to be also acting like our shield, so we'll connect those to ground. Then we got a couple pins left here. I have A8 and B8. These are actually do not pop, so we're going to place no connects on A8 and B8. And then we have our actual USB interface, D plus and D minus signals. So B6, B7, where B6 is our USB DP and USB DM is B7. So I'm just going to copy these directly from this page here. Actually, let's just grab this whole wire, paste it on here. And what did I say? I said USB DP is on pin B6. So we can hook that up. And let's just move that over here. And USB DM is on pin 7. There we go. Now we also need this exact same configuration on the other side here. So remember, USB-C, you can plug it in one way or the other and you'll get the same connection. So that's why you see these A1 through 9 and, or sorry, A1 through 12 and B1 through 12 are mirrored. So again, we're gonna copy this, paste this. Let's just paste it right here. We're gonna see if we can mirror this. Mirror horizontally, there we go. And we want DP on A6 and DM on A7. Awesome, there we go. So we have our USB connector. It has the CC pins populated with 5.1K pull down resistors to ground. We have our communication signals wired. We have our 5 volts. And now all we need to do is add our regulator, which is going to regulate the 5 volts into 3.3 volts for our controller. Now I've already gone ahead and pre-selected a regulator for us. This is one that I've used in several designs in the past, and it's just one that I am quite familiar with, quite easy to integrate, has some nice, nice little features about it that I like. So if we look here, it has an input pin, an output pin, and an enable pin, and then just simply a ground pin, right? No, nothing extra super special about it. Sometimes you'll have like an additional bypass pin, maybe some additional signal output pins, nothing crazy. This specific one that I have is 3.3 volt output, so you'll notice that there's no feedback pin because I know that I'm only ever going to need 3.3 volts on the output. And if I scroll down, it has this nice convenient WSON package, or we can even use this, where is it? The SOT23 package if you prefer to be able to hand solder these very easily. And then finally, one thing that I always like to look at, so our input voltage range from -3 to 6 volts. So USB, which can fluctuate a little bit depending on the load. That's more than enough on the input voltage range. And then if we keep scrolling down, there's this nice little chart here for the dropout voltage, right? Where the dropout voltage is if we have, let's say 3.6 volts on the input and we're trying to output 3.3 volts, we need to make sure that the dropout voltage is less than that difference to make sure that we can still regulate to that target voltage. So if we look at, our V out is between 3.3 volts and 5 volts, then our typical dropout voltage should be about between 150 and 215 millivolts. So what that means is if we're outputting 3.3 volts, our minimum input voltage should be about between 3.45 and 3.515 volts. Tons of overhead, more than enough. And yeah, so this part, TLV 755, let's go ahead and place that into our schematic. TLV. So there it is. And this is the WSON package, which I believe is the surface mount. So we're going to hook it up here to the input. On our output, this is where we're going to go to the 3.3 volts for our controller. So we'll grab this symbol, Control C, back on the power page, Control V. All right, now the enable, we basically just want to tie that to our input, right? So if it sees power coming from the USB, just enable the chip. Our grounds, these can go straight to ground. Nothing special needs to be done there. The only thing that I do recommend checking, and let me just bring up the datasheet again, is anytime that you're working with a regulator, it's always a good idea to double check what the EPAD pin is actually connected to. So we're using this WSON package, which is a surface mount package. And you'll notice that it has this thermal pad in the center. Now, 9 times out of 10, this is going to be connected to ground, the reference, return, whatever you want to call it. But every once in a blue moon, some chips will actually connect this to, for example, your VDD. Or some might even recommend that you leave it unconnected. So make sure that you double check. In this case, thermal pad, if we look, it says connect the thermal pad to the large area ground plane. The thermal pad is internally connected to ground. So because it's internally connected, theoretically you could leave it unconnected, but in general, connect it to ground. And then depending on, if you scroll all the way down, depending on the recommended footprint, sometimes they might recommend, so this is the SOT23. Let's find the WSON package. Yeah, so you'll notice here that they might even recommend having some vias placed here in order to improve the connection to internal ground planes. All right, so we've connected that to ground. These NC pins we can leave unconnected, so place, where's our no connect? There it is. All we need to do now is to add capacitance on the input and the output to basically smooth our power coming in. Now the value of this, sometimes you can reference the datasheet and they'll tell you what value you should use. Other times it's a little bit of guess and check. There's also some pretty complicated equations out there. Because this is a fairly simple board, and I've used this regulator quite a few times, 10 microfarads on the input and 10 microfarads on the output should be plenty. So let's go ahead and add a 10 microfarad capacitor on the input and the output. And then just make sure that you have enough overhead on the voltage rating for your capacitors, right? So if we look at my components here and I look at some of these capacitors, right? So this 2.2 microfarads is 10 volts rated. If you're trying to use like an 0402 and you find a 10 microfarad, it's probably not going to be rated for anything more than, I don't know, 3 volts or something like that. So either use a larger package with a higher voltage rating, or make sure that you find a part that has sufficient voltage ratings. Oops, Control Z. So we're going to connect these up. And these just need to be connected to ground. There we go. So we have our USB. We have our voltage regulator. We're getting 3.3 volts on the output of the voltage regulator. It's getting enabled simply by seeing power connected to the USB-C connector. The only thing that I want to add to this page specifically is, this board is going to have some mounting holes. I believe I have, so mounting hole 2.5 millimeter diameter plated. Let's go ahead and place a couple of these on this page. Not that they need to be specifically on this page, but because I know, this is kind of like my inputs and I don't know. I just want to place my mounting holes on this page. And then we'll go ahead and connect each of these to ground. So that way we can have some mounting holes on our keyboard so that we can screw it into whatever enclosure we decide to design. All right, so that's it for this power page. I believe in the next video, we will cover all of the different keys for our keyboard, right? So everything from our escape key to the number keys, A through Z, spacebar, plus, minus, all the keys on our keyboard. We're going to cover and create a matrix. And we'll talk about kind of the pros and cons of using a matrix and kind of how we can alleviate some of the problems that come with using a matrix rather than each key having its own dedicated pin. All right, guys, thanks for watching this video. Looking forward to seeing you in the next one. If you have any questions or comments, please leave them below. If you have any recommendations for future videos, please let us know as well. And yeah, I'll see you guys in the next video. Thanks for watching.